in IT industry, especially in blockchain. He was also head of India operations, sales and delivery at TCS Bengaluru, Karnataka. He has also been head of banking sales TCS BNCS. Apart from this, he was also business development manager for 4 years. He is passionate about emerging innovations in blockchain. On behalf of IEEE CIS Student Brand Chapter GHRC, I thank him for providing his gracious presence to join us today.
Thank you. Pragati, should I start? Okay. All right. Okay. Is my screen visible to everyone?
Yes, sir, it's visible.
All right. Okay. So, very quickly, the idea is to give a glimpse into what blockchain is about. You know, there are a lot of things that constitute this technology, and what I plan to do is to very briefly introduce blockchain to the students and everyone here on this call, and also tell what is in store in the future for them, for us, and for everybody who are part of the blockchain ecosystem, I would say. But before I start, I again thank you very much for giving me the opportunity to talk here. I'm quite delighted actually, and I hope to make a difference in you know, in terms of having the students see what this is all about and probably embrace the technology and probably even become entrepreneurs in this field. So with that, let me start the session. So one of the things is that in blockchain, while blockchain, before we go into blockchain, there are lots of problems in our industry in various verticals and every aspect of our lives. You know, right from I would say banking, financial services to manufacturing, to healthcare, to food, retail. You know, everything in between. And commonality in this slide, the pictures that you see here, the commonality, of course, blockchain is there. We'll come to that point. But all of these things that you see on the slide, each and every one of them have a problem. And the problem is not something that is light. It's actually a very large problem in their respective fields. And they've always been trying to fix that in some form of usage of technology, or maybe change in business processes and things like that, until the advent of blockchain. So did blockchain really move the needle in terms of getting you know, the answer to those problems? Yeah, well, actually, for the most part, yes. Blockchain, in conjunction with some of the other technologies and platforms available today, it is able to do a lot of good. It is able to solve their problems that were unsolvable before. That said, it is today not going to end world hunger or anything like that. At least not yet. The idea is that you guys, students here, may have an answer to that also if you start delving more into the details and into the strengths of blockchain. We will see to that. We will come to that point, right? So, before again I begin and start a deep dive session on blockchain, I think there are a few more questions all of you might have in mind. Um, uh, why am I talking to you about blockchain? What is really the intent? What is in it for you, right? And also, how is it relevant for you? What is it that you will need? What is it that you'll do in the future? I mean, if you get to know about blockchain, we will answer those questions also. And of course, we will I will also tell you what is blockchain. We will start with the first two questions, right? Now, here are some facts that I have seen in the last 3 years, that 3 or 4 years I've spent on blockchain specifically. It is considered as the most disruptive technology, in the recent times. This is actually something that was told by a very renowned company called as Gartner. Gartner is a world famous analyst company. They track all the movements in terms of technology, business around the world. They talk to various industries and understand what is happening in that field, in those respective fields, and then compile changes, forecast or predict changes, and so on. So these guys actually have already said this is one of the most disruptive that they've seen so far. Another gentleman by name Mark Cuban, he is an entrepreneur, he's a billionaire based in the US, and he says that it is the new internet. When he says it's the new internet, you can actually imagine how 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 much of an impact this technology is having today. And he says that he's looking at blockchain like he saw the early stages of the internet, and how it can actually transform a lot of lives in the process, the way internet has transformed our lives today, right? And that's a big thing. And so that is what is blockchain. And in terms of money, of course, it all comes down to economics. What they are saying is, companies are going to start putting a lot of investment money into developing solutions that can help them. And as of next year, by next year, in the next 12 months or so, we will see about 100,000 crores um, being invested on this technology. That's a lot of money. I mean, if you think about it, that is how much we want in terms of, if we want to have an infrastructure that is as good or maybe better than the most developed countries around the world. That is, I'm talking about India. If you want India to have an infrastructure that outperforms the best of the best today, you will need so much money to build a new India across India. And that amount of money is just spent in 1 year by some of these institutions. So you can see how important it is, right? And why are they investing? Because they're going to get back a return on that investment. They're seeing a lot of money coming back. They can save 30% on infrastructure. They say they can also save. If they spend 100,000 crores, they are going to get back 120. That is what they're seeing, 120 or 130 crores. So people, it's all simple economics, right? They're going to get money. If they spend money, they get money, and that is what is happening. And this is only going to grow. We are talking about 11 billion in that is 100,000 crores in the next 12 months. In the next 5 years, it'll be 10 times that money, that amount. So that's a huge amount of investment. So coming to what is in it for you, well, right here again, economics. That is, there are going to be more opportunities that you can think of in this field than you have today. Blockchain is going to help tap those opportunities for you. There are going to be more job prospects, huge potential, and it doesn't matter. So most important thing is, it doesn't matter if you are an electronics engineer, a computer sciences engineer, or industrial electronics or chemical engineering. doesn't matter, because every bit of every domain, be it biotechnology, be it electronics, be it computer science, every technology, every domain will need blockchain. So that's the beauty, and that is how you should see. I mean, how important it is in the real world. So that said, the big question, right? What is blockchain? Is it is it some great change movement? Out of the world technology? Actually, no. It is a very simple thing. Blockchain is just storage of data, nothing else. It is like today you're storing an ex you some let's say you're storing numbers in an Excel sheet, a spreadsheet. It is very similar to that. How it saves that, how it stores that information, that is the key. That is its strength, and that is where the differentiation lies. We'll talk about that, but I hope you understand that we are looking at just storage of information, and that is what is transforming. And if you go back to what I said about internet is about what? Internet today is about, say, storage, storage of information. So if you want to access information about science, you can go to popularscience.com. If you want to understand or see what's happening in India in terms of stock market, you can go visit economictimes.com. So what are you doing is you're accessing data that is stored, which is what is internet is about, and that is exactly what blockchain is also. The way it stores data is, of course, very different, like I said, and we will come to that. So any technology, right? There is a movement, there's an evolution. So it actually started way back in the 1400s when people were using tablets, stones also, way back, of course, and then bookkeeping and everything that was there. We used to maintain ledgers to see what were the payables and what were the receivables, debit and credit of information, of numbers, costs, money. So it was all about, say, having some way to store the financial information. Okay, that's what started all these things. So it started with financial information, then it moved into saving that in a database, a relational database. I'm sure you've heard of Oracle database, or IBM's DB2, Microsoft's SQL. There are all a lot of open source databases also, Postgres and MySQL and so on. All of them, became the mainstream storage places, where you store information. And today, internet, whatever that you access on the internet is stored in one of these databases. It has moved from, books and very basic spreadsheets to databases. And from databases, it is now moving into blockchain. So that's the evolution of that technology. Essentially, that is what is happening. Like databases can be used in every industry vertical, you are going to be using blockchain in every industry vertical, right? So that is essentially the way it has moved through the ages. Now, who invented blockchain? This is a question that I don't have an answer to. Nobody actually has an answer. It is interesting, isn't it? There is rumor that a gentleman by name Satoshi Nakamoto, a Japanese individual based out of Los Angeles or San Francisco, he invented blockchain. That is the rumor, of course. And why he invented blockchain is basically he wanted to create a currency that is not regulated by any central authority. What that means in layman terms is he did not want an entity like Reserve Bank of India to create the currency, maintain the currency, regulate the currency, see where the currency is going and coming, and so on and so forth. He did not want any government intervention. So he wanted to create a ledger. He wanted to create a financial system that is out of the reach of governments. Now, and to create that financial system, you need to have a ledger, basically a bookkeeping, a record, right? A record of transactions, record of movement of transactions. Now, that record, to save that, he created blockchain. He didn't want to use a database like Oracle or DB2. He created his own way of saving that data. And that is how he created blockchain. Now, like I said, Satoshi Nakamoto is just a name. Nobody really knows. There's a lot of rumors. If you find him, I think you should start talking about him or her, whoever that may be. But good luck finding, right? So, so the concept again, in summary, blockchain is basically saving information, in a file. Okay. Why is it called blockchain? Because it is saved in blocks, and each block is connected to the previous block. Okay, and so on and so forth. So blocks are connected together, it forms a chain, and so blockchain. Very simple, nothing extraordinary about that name. And every link that happens, the block connecting to the other block, the reason they are connected is because the forward block has information about what the previous block contains, and the previous block has information about the previous block behind it, what that contains, and so on and so forth. And so you cannot really break, and here the important thing is you cannot really break the chain. It is always like that. You keep adding blocks into the chain to build that data, right? And if you want to edit or delete, you create a new block and say you're deleting something behind that or behind that. I'll talk to you about that a little in a little more detail. But essentially, it is just a database. It has links to all the data that has been stored in the other blocks behind, and you can actually go all the way to the genesis or the inception of a particular data when it was stored. You can trace the way back, right? So if you had stored some data in 1999, imagine it was there in 1999, I stored the data. You can actually go back to that point and say, hey, I stored the data on this day, and nobody can tamper that. Nobody can change that. But there are a few things, before I go into more details, there are a few things that you should know. A few words that you should be aware of. The block and the chain, you already know now. There is something called as consensus. Consensus is basically a democratization process, voting, basically. That's consensus. You'll be hearing a lot about nodes and validation. Keep that in mind. And of course, transaction. And a very important part of this whole blockchain is something called a smart contract. We'll clear the words as we go through this presentation, but keep these words in mind when we start, so you know what to relate to and why it is being used. So the block and the chain, you understand, right? It is essentially a train, right? Think of it like a train. And all the coaches are the blocks. The engine is pulling it, and you cannot just remove when it is running. You cannot just remove a coach and then join the other two together. It is the same concept here. You can never break anything. You cannot remove a block from the chain. They are there for life, and that is how it is. The engine is running, the train is moving, and you have the data. If you want to add, you just keep adding the blocks, and the engine keeps pulling all the blocks together. And that entire arrangement is a chain, so it keeps going, right? Now, before I go a little more into more details, there's an important concept you need to understand. So traditional databases, right, like Oracle, DB2, they're all centralized in nature. It's like imagine a cycle or a bicycle or a motorbike's wheel, right? You have a hub and spokes coming out of the hub, and you have the tire around it. So the hub is the database, right? And the spokes are the connectors. So if all the people who want to access the database are connecting through the spokes to the hub. So it's a centralized data area. You have one database somewhere in a data center, and everybody connects to it. So same way if you want to access economic times database is somewhere out there in the cloud in a data center. You access it from your mobile phone, from your laptop, from your desktop. You're just connecting. The data is not here on your laptop, desktop, or mobile. The data is saved in the hub, in the data center, in that centralized area, right? What is a decentralized um, data model, right? Decentralized is obviously there's no hub. Okay, in this case, economic times data will reside on your phone, on your laptop, on your desktop, and it does not reside on the data center. There may be a copy of that in the data center, but the same copy of the data is also residing on your phone, on your laptop, on on that desktop that you're accessing from. So essentially, it just means that you have complete ownership of the data on your device, and that is the decentralized model. Now, decentralized models are not really good for everything. They're good for some use cases, not everywhere. Like economic times, you cannot have so much of data stored on your laptop or on a mobile device, right? So that is good to have a centralized system there. But let's say you want to save your Aadhaar card details, your driving license details. It's a lot more safer if you have the data on your phone rather than having to connect to a centralized place, which could be susceptible to hacking and things like that. So anything that you store, if your health records, if it is there somewhere inside inside a central database, it is still susceptible to somebody stealing that. Even with safeguards and everything, we have seen how much of that has happened in the US, in UK, and other parts of the world. People have hacked into databases like that and have stolen information. I'm sure you've read a lot of news articles around that. Amazon loses some data, Facebook loses some data to somebody hacking it, and so on. But if let's say that the data that you own is under your control, that's great. Nobody can hack into it. It's just you. Now that is where decentralized structures really help, and this is where blockchain works. So coming to the next important part of how it actually saves the data. Why is it different from the rest? So we'll come to what you call as a consensus mechanism, right? In a decentralized um, data structure, what happens is all the participants who are looking to store the data, they all have a say in whether the data is the correct data or incorrect data. So you have a say. It is a democratic process, voting process, and that is what is called as consensus mechanism. So only if everyone has the vote is when the data is stored. If not all people have given their vote for saving the data, it doesn't happen. So here is an example, right? So what you see on the screen is I think a killer whale, right, coming out of the sea, just looking around. Now, let's say if you include the children in those picture, children and the adults, there are about 11 people. who are looking at that picture, who are looking at the whale coming out of the ocean, coming out of the water, right? Now everybody is seeing it. So everybody says, yeah, yeah, okay, I see it. There's a whale that's coming out of the water. It is peeking out. I don't know what it's going to do, but I see it. It's there. So everybody say yes, and the moment they say yes, the data you see is stored uh, in the block. That is what happens. That is what is called as consensus. Now, the moment it has the consensus, the data gets stored into the block. Now, let's say another image. Here, well, the whale is now coming out of the water and diving back in. Right now, well, five of them say it's the same whale. It's the same exact whale. It's diving back in. It was peeking out. Now it is going back into the water. Five people say, and the rest, the other four are in this case six people say, and the other five say no, no, no. This is not the same whale. I think this is a different picture. This is a different whale. It's not the same whale. But in this case, a majority of the people who saw that, who were seeing this picture, say it's the same whale. I'm convinced. Let's go ahead and vote. And six people say yes, five people say no. Because the majority of the people agree, it gets saved. All right. Now, there's another scenario. Right. Now, the whale's going inside. It is gone. Now I see the tail only. Actually, my daughter said that it looks like a cartoon mustache. Maybe it does, but I feel it's still the whale's tail fin. But let's see, that's debatable also. Now, when we see that, five people or six people in this case say this is not the same whale. What's going in is not a whale at all. They may in fact think that it is a mustache of somebody of a cartoon. So I'm not going to vote. So they don't vote. Four people still, or five people in this case, still say yeah, okay. So majority here say no. A minority of the people say yes. Because the majority say no, the data doesn't get stored. So this is a simple way to explain how data gets stored in a blockchain database, in a ledger, as it's called as in the technology. So unless there is complete consensus or majority consensus, the data does not get committed into the database. And this is a great thing. Why is it a great thing, you may ask? Instead of having one person decide, or a database administrator decide, or an application decide what data goes in and what data goes out, which data gets deleted, here in this case you get to vote. You have a vote. You have a say in what gets in and what gets out, what gets deleted, what doesn't. Now that's a great thing if you think about it. In terms of privacy and so on. You have a voice that can be heard, and you can make sure that you say no. But all these things, keep in mind, you're not literally voting. You as an individual is not voting. Your device is voting. This is digitally voted. There are algorithms behind the scenes that say they are called as consensus algorithms. They say, okay, I see all the devices are in agreement, and we go say yes. I see that all the devices are not in agreement, so we don't save the data. There's a problem. So this voting mechanism, this algorithm, is what will make sure that your data is going into the right place and is secure. And the moment it goes on the blockchain data, all the data that's going in there is cryptographically hashed. In simple terms, it is encrypted. It is encrypted unless you have a quantum computer in your backyard. You cannot break it. You cannot break the hashes on these blocks. Impossible. Of course, if you do have a backyard, a quantum computer in your backyard, it would definitely mean that there is some other party out there who also has a quantum computer in his backyard. He can then encrypt it from a quantum perspective, so you'll still find it difficult to break it. So that said, blockchain is extremely secure because of the consensus mechanism. Now, we talked about block talked about chain. We understand what is consensus. Now we will come to nodes, validation, or what they call as validators. Now, in a decentralized system, like I was telling you, when people initiate transactions, when you initiate a transaction, when you upload something, when you download something, when you want to save something, right? All the parties, all the members of that blockchain, of that ecosystem, of the blockchain ecosystem, all have to say yes, like I said, through the consensus mechanism. Now, here is what happens. So we have different systems. You have a laptop computer, you have a desktop somewhere, you have a mobile device, you have some other party who has another a tablet computer, whatever it is. They all work in synchronization and ensure that data is being exchanged. Okay, but while data is being exchanged, there's a possibility that you can make a set of people, usually odd numbered, not usually but always odd numbered devices, as validators. Validators are the ones who actually check the authenticity of this transaction that is going to be saved. They make sure that everything is running as per the design of that exchange of data. So those are the participants of that system who validate or authenticate those transactions are called validators. The other parties are basically, even including the validators, are also nodes. What they do is just initiate transactions. Validators make sure that the transactions are authentic and ensure that transactions get saved. So that's the validator and the node option. Now you can see I have just explained the same thing in a different way. On the right hand side, the red ones are the validators, the 3 validators, and the rest of the 3 are basically nodes. So the user nodes, as we call it as, initiate transactions, and the validators make sure that the transactions are meeting the terms and conditions, right? And that's how they get saved. You can make all of them validators. You can make all the participants validators, but validators need a little more computing power because they are the ones who will then encrypt that data and save it. So there's a need for a bit of number crunching ability. And so you normally don't give that ability to every user because it is going to just take away all their compute, and the rest of the applications that they may have on their device might suffer because the compute is quite strenuous on the device. So we make a differentiation there on nodes and validators. I'm sure you have also heard of mining. In Bitcoin terms, mining is basically validation. Miners who are all there are incentivized. They get a bit of money because they validate the transaction. They validate the transaction by using large number of computers. They use the algorithms that are given to them. They crunch the numbers and make sure that the data is saved. So for that work, that is where you see a lot of people, a lot of startups are also into mining, Bitcoin mining. Basically, they are validating transactions and they get incentivized for that work that they are doing. So moving on to the next important thing, which is a smart contract. If you remember the analogy I gave about the train, the blocks and the engine. The engine of the train is actually the smart contract. Smart contract is essentially the heart and the nervous system of the entire blockchain system. Why I'm saying it's the heart and nervous system is because if you want to save the data and if there are terms and conditions for saving the data, all those things are governed by the smart contract. The consensus mechanism, the algorithm that runs the consensus mechanism, there are different kinds of algorithms that you can design to maintain consensus. So that algorithm, any other terms and conditions between participants, that you want to also make sure are adhered to, are also something that saved in the smart contract. And once the smart contract is saved, it is executed, and the execution process of that smart contract is what saves the data into the block. And so there are four stages essentially in saving the data into a block. The first one is, of course, like I said, you have to create the conditions. You have to tell what the key conditions, key terms are to save the data, right? So you create some business logic. That is the first step. Second step is the validation mechanism. You create those validators. You tell the validators what to check, okay? And if they all meet, if that transaction meets all the terms that you have put in, they check every box, in terms of terms, the conditions. Once they do, the validators are done. They move to the next stage, which is what is execution. That is, the code will be executed, the cryptographic algorithm will run, and it will save the data into the blockchain. And at the same time, it will also ensure that if there is any additional work that needs to be done, like sending an email, sending an SMS, or updating something else, that is also done as part of the process. That execution process is fine. Then once it is all done, there is a finality. The block is created, it is all wrapped, and it can move to the next task at hand, and that is the fourth one. So this all happens in a sequence. So that is why the 1, 2, 3, and 4: create, validate, execute, and finalize. So the smart contract is what runs blockchain, and this is where you guys here on the call, all the students here, if you are going to develop something on blockchain, you're essentially creating smart contracts. You're creating smart contracts that can work specifically on a lot of things that are out there. We'll come to some of the use cases in the next few slides. Okay. So let's create a simple transaction on a blockchain. Let's say I owe money, right? So the idea is I create a transaction where the transactional data is stored in the blockchain. Now, in this case, let's say I want to, I need to give money to Pragati, right? And I want to use an app that uses blockchain to create that transaction to give that money. Now, what I do, I basically use a device. Say I want to send $1,000 to Pragati, and these are the details: Pragati's account number, my account number, my phone number, her phone number, everything is packed in. I send. Now, when I send that, it goes into the block. Well, the block is not created yet; it's just temporary. It's a staging area. The information is gone, is wrapped in. It goes to all the nodes and validators. They all say, yeah, okay. We have checked Raghu, we have checked Pragati. They have the phone numbers are okay, the account numbers are right, the money is right, there is balance, everything is checked. They say, okay, it's good to go, and then they proceed. The transaction is saved into a block. The block gets connected to the previous block, and once the block is created, there's an email that goes out that says it sends an email to Pragati saying you have got $1,000, and I get an email on my side saying that my account is now lower in terms of balance by $1,000. And this entire thing happens instantaneously on a blockchain. There is no way, I can say, for one, that I did not initiate the transaction, because everything that happened is recorded, stored. Every key, every thing I did, every information that I sent is stored, and this is called as provenance. The ability to trace the genesis of a transaction, that's provenance. So if somebody wants to come here, Gauri wants to, let's say, check if the transaction is genuine and if there is no dispute, she can just go ahead and audit, and she can see all the way to the time when I started the transaction. So that's called as provenance, a very important term that you need to keep in mind when you're talking about blockchains. Second important thing is the consensus mechanism, right? So the people who are part of that ecosystem, it's a payment transaction. There are, of course, multiple parties in that payment ecosystem. It could be like a UPI as an example. There are so many contacts. All the contacts also understand that there was a transaction. Then keep in mind the users of the participants, they can only say yes, the vote for the transaction. They cannot really see what the data is in the transaction. You can actually mask that information. So only Raghu and Pragati know what happened, as in the $1,000 was sent to her as part of this transaction. Nobody else knows that Raghu sent Pragati 1,000. They only know that something was sent from one party to another party, right? And that is clear because it meets the terms and conditions of the transaction. That is what happens, and the consensus takes care of that. Then immutability. Now, this is a very interesting concept, and the concept is, if I want to, in this case, delete the data that is here, if I want to recall the transaction, if I would say, oh, by mistake, I sent 1,000, okay, or better, I'm a hacker, all right? I want to erase Pragati's account detail and then move that money or add my own account details and get that money for myself. Leave Pragati out. Raghu will think Pragati, it has gone to Pragati, but a hacker may intercept and take that money to him. Now, let's say that is a scenario that we can think of here in this case. Here with blockchain, you cannot. This doesn't work. Why? Because the block that is created here, the green block that you see, once it's created, it is created. It is like etched in stone. You cannot erase it. If you want to make changes to this block or the information in this block, you have to create another block and say, okay, there's, I'm changing the transaction. I'm not going to send it to Pragati. I'm going to send it to Gauri instead. But another block is going to get created for the same movement of that data. So there is no way I can delete what has happened. Now, this is immutability. So imagine if if a bank today's banks run on centralized computers. So imagine if a hacker hacks in and takes away all the money, deletes the records of the table, may not even take, he just deletes the records of the table. That's it, poof, everything's gone. Now, what do? There's nothing you can do in this case. As long, you have to just hope to God that there was a backup database somewhere, and they can retrieve the data back immediately. What if that is also not the case? Then we're literally, all the money down the drain. That's it. In blockchain's case, that is actually impossible. You cannot delete that data. You can never. So it will store every bit of thing, every bit of transaction, everything that went on, as long as time itself, from the time it was started until the time you stop that, the entire application, this data will always reside. Even after you stop the transaction, the data is always going to be there because you cannot do anything with it. Now, there are questions about privacy. There are a lot of governments who are questioning, because they are saying there's an act called as right to forget in Europe. Um, this is mainly, I can request right to forget, I can file right to forget with Google. So Google will delete everything that it has about Raghu Krishnamurthy and send and confirm, acknowledge, and saying, okay, you have been forgotten. In blockchain's case, it is actually not possible. So there is a problem here. So, but while I say that while the data is still there, it cannot be accessed at all by anybody except for that individual. So it is very safe. It is just that you cannot forget. So Europe, the European Union is actually looking at updating that law of right to forget and saying if it is on blockchain, it is okay. But there has to be a new block that has to be created to say there should be no mention of Raghu Krishnamurthy from this point onwards. So from that point onwards, there'll be no Raghu Krishnamurthy. But Raghu Krishnamurthy will still reside in the previous blocks. So at some point of time, if Raghu Krishnamurthy wants to go and check, it is still there. So that is immutability. And the end state is finality. That is, completion of transaction. Everybody's happy. So we understand now how the blockchain works. We understand finality. So the key points that you need to keep in mind is, blockchain helps in ensuring the data is tamper-proof. You cannot tamper at all. Okay, the provenance or the ability to audit, go back in time, find what has changed over the last, few time frames. You can do that. That is called as provenance, and it is extremely secure, probably the most secure today. And there are no middlemen, so nobody has action or right over the data. There is no middleman at all. And every action is recorded. So there's a very clear audit trail of what has happened, and there's no control, centralized control. So it is immutable, tamper-proof. It can be audited. It is very secure. It is decentralized. You cannot reverse it. It's irreversible. It is extremely efficient way of storing data. These are the things that are making blockchain very attractive today, and that is the reason it is being looked at as the new internet. Now if I go back to the slide I showed you earlier, now I'll tell you how things are changing in terms of businesses, right? It's an amazing set of things that have happened in the past. An example is milk. There were dairy farms across in the US, who used to give milk to milk processing centers. But by the time milk arrived at the milk processing center, there were cases where the milk had gone bad. Now, how do you know who is at fault? Is it the cow? Did it give bad milk, or is it the container? Did it have lemon in it, which made the milk bad? Or is it the truck, which was really hot, did not have the air conditioning on? Is that the reason why the milk went bad? Is it in the processing center itself where there was a mishap which made the milk bad? So how do you ensure that all these things, all these disputes, all these who did what and when, how do you solve it? And this is where blockchain came. Of course, with technologies like IoT, everything got stored in blockchain, right from temperature or the health of the cow to the container the cow is giving the milk pouring the milk into, and when the container gets into into the truck, the temperature of the container, the temperature of the truck, the humidity, the other environmental factors that are there. Was a day cloudy? All these things, everything was being stored on blockchain as part of the process. And then when things happened, you go back and it saw that there was a clear understanding of how the progression happened, and blockchain made that entire process more efficient. And there was no way that a dairy farm would say, I am not at fault if that person is at fault, or no way he can say that the cow is healthy when there is something that has gone wrong with the cow, because the IoT devices have picked up and they have saved everything on blockchain. And nobody can say this blockchain got hacked, because it is not hackable. So this way, they ensured that whatever disputes that were there were resolved instantaneously. Similarly, diamonds. You may have heard the concept of blood diamonds. People mine diamonds in, um, you know, professionally with proper, processes and everything. And there is also mining of diamonds by people who are not following processes, who get child labor involved. They mine under very extreme conditions, unhealthy conditions, inhumane conditions, and these diamonds also come into the market. Now they wanted to have a way to control that, to ensure that the diamond you may tomorrow buy for your wife, for your fiance, is coming from a place that ensured very humane treatment for the people, for the miners. There is a very clear environmental controls, very clear sustainability efforts. All these things you would want to know. Now that is where De Beers is a very famous um, uh, diamonds jeweler actually, and a diamond exporter. So, and also a miner. So it mines. It has its mines in South Africa. They implemented blockchain. I think it's called as diamond chain, where everything that happens from the point it is mined to the point it goes to the jewelry store for you to buy, is tracked and traced and authenticated, certified for you to see. At any point of time, you can see how it progressed all the way through. That is what happened. Coffee beans are being looked at for the same reason. Flowers in Amsterdam, Netherlands, when it is being exported to Australia, are being tracked this way using blockchain. They're also now using blockchain as an investment. You know, let's say Hiranandani in Mumbai has a property that is now up for grabs. It will cost 5 crores. Now I am a TCS employee. I cannot afford 5 crores. So what I do is, or what Hiranandani says is, why don't you take a small part of the property, maybe 100 square feet. That's it. You don't have to say take the 5,000 square feet of space. So 100 square feet cost me 10 lakhs. Now I say, okay, 10 lakhs is something that I can afford, but how do I just buy the 100 square feet? Now this is where blockchain comes into picture, and something called as tokenization. Now what I can do using blockchain is take that 5,000 square feet house and split it into tokens, multiples of 100 as an example. So I, buyer, can only take one token, which is 100 square feet, and buy that real estate space digitally, right? And at any point I want to sell, I sell just that based on market value. So if it moves, if the value goes up by 20%, I just sell it and make the 20% profit. I'm just selling the digital part of that house that I own, and that's a great thing. That is all. That is what is being done in real estate. That is, and it is a great way to invest. While for people who may not be able to afford all the entire house itself, but they still want to invest in property. Now, there's several cases in pharmaceutical industry. Drug distribution is a problem. When you distribute drugs, there is always pilferage. People may steal, people may go. So if they use blockchain in the process of distribution, you always know where each and every drug ended up at. And this is being looked at as a best option for the drug distribution industry in the US. So there are several cases, in petroleum, in mining, in even in energy, sustainable efforts. Solar energy is being marketed that way. Marijuana, the drug, or hashish, I think that's what they call, is also being regulated through blockchain. So if you think about it, there's amazing stories that you can read about on how blockchain is actually changing the way we think about businesses, and it is all up to you guys to start building those things into reality. So blockchain helps in tracking, tracing, things. It can help anticipate changes, movements, goods. Logistic industries will get help with blockchain. It will improve efficiencies significantly, and compliance, the ability to audit, go back in time, see what has happened. Easy peasy, right? And there's clarity. Everything is stored, safe, immutable. Transparency is there, tamper proof, right? So that is what is blockchain. So there are, of course, some misconceptions. Blockchain is Bitcoin. No, it is not. The Bitcoin is an application that has been developed on blockchain. They are not the same. Cryptocurrency is the only thing that works on blockchain. That is also not true. Several, like I was talking about, that is being developed on blockchain. It is not only for the financial sector; it is in every sector now. Smart contracts can replace real life legal contracts. Part of it is true, part of it is false. If you actually have a contract today, and some of the contracts can be, if they can be digitally enforced, okay, like term of the contract and things like that, you can put it on blockchain. You can create a smart contract app and put it on blockchain. Data can never be altered on blockchain. Well, it can be altered by adding another block, but you cannot alter whatever that was already there, right? So, and people think, like I was telling you, it is the next internet. A lot of people think it is blockchain is the answer to everything, a solution to everything. Every time there's a problem, I'm called and said, why don't you use blockchain? But it is not the answer to all of the world's problems. Only there are very few problems that there are a lot of problems that we can address, but not everything. Blockchain, in fact, the drawback is like a train. As you add more coaches into the train, it becomes harder to pull. So you have to understand, make sure that the blocks are used efficiently. You cannot load all transactions on blockchain because it becomes really difficult. Today, Bitcoin, for the validation to take place, takes about 10 minutes because there are millions of people who are using Bitcoin. So it takes 10 minutes to finalize a transaction. And that is because it carries so much of baggage, so many blocks behind it. So it is not always an answer. There are multiple types of blockchain. There are public blockchains. Bitcoin is open to all. You can have a wallet and you can start trading in Bitcoin. Of course, not in India, but in some other places. There are private blockchains, which is only limited to invitation-only people. So if you have an invitation, you can start working or transacting within the blockchain, within that blockchain ecosystem. Then there are consortium hybrid blockchains where part of it is public, part of it is private. Private because if there are some data that should not be shown outside, so that part of that data is kept as a private blockchain, and the rest is public blockchain. So a lot of ways we can delve more into it. In the interest of time, I'm not doing a deep dive on these kind of things. My intent is to give you a understanding of blockchain, and as you start looking at it, I think most of the things and most of the sources, a lot of sources on the internet that will actually give you all the things that I'm talking about. So it'll be a lot more easier now once you understand the concept. What do we do in TCS? Something that I really want to also talk about. We build applications. We also have applications that are already ready to use. Loyalty management, rewards, for example, is something that are on blockchain. We have solutions for it. We create applications on blockchain. There are multiple blockchain platforms like databases. You have Oracle, DB2, SQL, MySQL, Postgres, yada yada yada. You have similarly a lot of blockchain platforms. There's something called Hyperledger Fabric, Ethereum, Quorum, R3, Corda, several, Sawtooth, several graphene, and if I keep thinking, I'll keep thinking about so many. But there's so many databases, blockchain databases, and all of them use different ways of creating applications on those databases. What we do, we have something called as a dev kit here. The first one, the dev kit basically, if you are good in Java, that is what you need. You just use the dev kit to create the business logic. Everything else about blockchain, it will take care of. So if you were to create, let's say, it takes a year for you to create an application, using dev kit, you can create it in 3 months or even less, because most of it is done. You just have to create the business logic in Java. So, and you can deploy it on any blockchain platform, any database out there. So it makes it easy, right? And we have solutions. That is the point, the option 3. And then we have something called as a gateway that helps you connect, integrate blockchain systems together. And there's also something called as a command center. If you have so many nodes and validators, you have to maintain, add members, remove members, see if the transactions are flowing through, understand the health of the entire system. You need something like a console or a command center. That is what it does. So you have a command center, right? Now, this is not just what we do. I mean, we can also help you guys. In fact, you are the next generation of people, taking all these things forward. So we can help you in building careers in blockchain. There's so many options, from being a blockchain developer to an architect to a designer, cryptocurrency research analysis. There's so many out there, and it is only increasing by the day, the type of career options in blockchain. TCS also can help you get hired quickly. We have programs for students to help them start creating applications on blockchain, understand blockchain concepts, build, help integrate blockchains together. All these things are being done. We have trainings, around that. We can help you with those trainings and ultimately improve your resume so you can get hired quickly. And as part of that, you can also, whatever you're interested, if you're interested in, if you're a mechanical engineer, as an example, we can help you understand how blockchain can be used in automotive field. If you are into biotechnology, we can tell you how life sciences healthcare is using it. If you're interested in chemical engineering, if your major is chemical engineering, I can help with taking you to a place where the pharmacy uses blockchain to improve the entire process, and I can bring you up to speed. I as TCS can bring you up to speed on that, and essentially help you get jobs quickly, right? Whatever changes that are happening around all these areas, we can obviously help you there. And this is ever changing field. A lot of things are happening, so you have to keep yourself informed, and this is what we call as evolving skilling based on demand. And this is again something that we can help you. We have an Ion. You may have heard, we have an Ion platform, TCS Ion. You can Google it, where you have several such courses that help you reskill, upskill on demand whenever you need. And of course, all these things, when you do, ultimately, it definitely helps in improving your compensations and bringing you more opportunities, and also create an entrepreneurial, capacity inside you. So you can, in fact, then build your own applications, and maybe maybe who knows, you can create a unicorn again. Today, there's so many unicorns, from Ola to Uber to everybody else, and there's blockchain is still very nascent here in this place. So you can create, you guys can have three other unicorns, billion-dollar companies. So we can help you there also. That said, I'm really glad I gave this session. I'm really happy that you guys gave me the opportunity to talk about it. If there are any questions, I'm really happy to take them. I don't know how many or how the format of the question and answer session is, but I'm open for any question that you may have.
Thank you so
Thank you
much,
so much,
sir, for
sir, for
delivering an
delivering an
amazing
amazing
session.
session. No
Uh,
problem.
Now we have arrived to the question and answer round. The session is open for questions. Audience can unmute themselves or drop it into the chat box or even raise their hand.
So while you guys think about questions, some of the questions that I do get is I'm in my final semester or in a final I want to do an internship on blockchain. That's definitely an option. TCS, you can apply for internship on blockchain or even AI. We are more than happy to take interns. We are ready to help build that career around some of the things that you're interested in, and that is what internship is all about. So that's something that you may want to keep in mind. Is blockchain similar to peer-to-peer system? Yes, it is. You're absolutely right. It is a peer-to-peer system. It is exactly that. And another question that I also you may have in your mind is mm, how are the opportunities in India on blockchain? The opportunities are huge, from Reliance to Tata's to all the startups that are out there. They've all started embracing blockchain. Our Honorable Prime Minister, in fact, has said that blockchain should be in the forefront of adoption in India. And with that in mind, there are a lot of companies, a lot of state-owned companies also, and private companies that are building expertise in blockchain. So that is something that you can tap into. Keep in mind, as students, one of the things that you would want to get into is something that is new. The moment you get into something new, you get to be in that niche area for quite a long time, and that will create or shape your personality differently. That you'll eventually become more like an architect as you grow through that technology, and it is definitely going to help shape your career, shape your future, and that's very important. Right from if you see some of the people who are really successful in their fields, all started on very key new things. Right from Elon Musk as an example, he started with PayPal when the electronic payments were still nascent, but that is where he started his journey. And so when you start journeys in those niche areas, you always get to grow into really successful young men and women, and that is important. So blockchain, AI, we are something that are forces to be reckoned with. So no other questions. I mean, I'm an amazing teacher or a terrible one. Actually has to be one of them. If I'm an amazing teacher, I'd want to think about that. I want to become, I would comfort myself that I'm an amazing teacher. So I'm thinking that all the things I said did not go over the top. You guys understood what I said, and I'm glad. So, so otherwise, I cannot sleep today. I'm thinking, oh, I was really bad. But no, you're welcome. Thank you. Um, Back to you, Pragati, Gauri.
Thank you, sir. Teachers are the leaders in transforming education and technology around the world. We feel extremely lucky that we have Professor Achama Thomas as a chapter advisor. I would like to request a chapter advisor, Professor Achama Thomas, to enlighten us.
Yeah, thank you, Pragati. Good evening, sir. So on behalf of our institution, G.H. Rai Soni College of Engineering, I would like to thank you for your sparing time from your busy schedule and delivering this interesting and very engaging session, sir. It was definitely a wonderful session. I'm sure the students have got a very good introduction, and in fact, you answered a lot of questions that I had in mind. So just one thing that I have from my side is I wanted to know, like, a little thing about us is that just in 2019 we started with BTech in artificial intelligence, and this year we have started with BTech in data science. So these two courses we have started, and so our institution is quite old. So we were established in '96. I do not know if you've heard of our institution before this, but it's one of the premier institutions here in Nagpur.
Okay.
And here we have a very good connect with the TCS. We have Mr. Arvind Kumar sir, who is the center head, and we have very good connection with the TCS institute company here. Anyway, sir, what I wanted to ask you is, so we offer industry offered electives, like as in we have the electives. We would like to join hands with the industry to offer those electives. So if we wish to offer, say, a course on blockchain for our students, how do you think TCS can help us?
We can. I mean, we can offer the blockchain as an elective. I mean, we have already started. In fact, we started an engagement with Auckland University to give blockchain as an elective course. We started with that, but now it's gone mainstream. So we have a plan. In fact, we've already started reaching out to a lot of institutions to look at blockchain as an elective course. We understand the credits that are needed and the system behind it. So we have, consulted the academics and created the courses based on these credit requirements. So I'm more than happy to connect with you to introduce this as an elective. And I think it is very important. Blockchain is least understood, but actually having the most potential. So
okay.
I'd be more than happy to help you with creating tailoring an elective course.
Okay. So, but would we get expertise from the industry for delivering the?
Yeah. So as part of that, Ms. Thomas, we give our own people. So I can come and talk. My team. There are several industry specialists on blockchain who can come and talk. As part of that course, as part of the arrangement, that is also part of the equation.
So how do I go about it? I mean, to start with, whom should I? I mean, should I send you a mail or should we be connecting?
Yeah, you can connect with me, Mr. Thomas. Okay. I will then connect with the right people and we will get this started. Not a problem.
Okay, wonderful, sir. Wonderful. So I'll definitely get in touch with you post this session. Definitely. And let's hope we can do something really good for the students, right?
Absolutely. I'm quite excited. I think the students need to know what this is about, and our intention is also to ensure that our the next generation of students get a hang of what is coming. We always. At least my mother used to say that, we should never be late for we should be ahead of time in a bus station or a train station. And normally it doesn't happen. We get caught in something and we always come late. And we don't want to do that in terms of, in terms of getting ahead on blockchain. We are at the right stage in India and around the world. So I think this is the time we need to learn and engage ourselves in this technology, and take it forward. It'll be good for the students, good for you.
Yeah. So, sir, in fact, I would like to share this also, that our students, we have a very, very active lot of students. In fact, so this particular thing, this IEEE CIS, so we have a professional society, and in 2019, 2020, we started with this IEEE Computational Intelligence Society. And this lecture series that you see is a part of that Computation Intelligence Society. And this is entirely run by the students, sir. So there's a student chair, and there's the entire team who's working behind this. I am the faculty advisor, but I have very limited role to play. So it is totally led by the students, and they've been doing a fabulous work even last year and this upcoming year also. And even all the students who have joined the session, sir, they have done it on their own. Let me tell you that we have IT, CS, and AI, data science, from the first year to the final year of the students who have joined in for this session. So they're all the ones, the interested lot, who have come on their own without any pressure from anyone. So, so that's what. So I see a lot of enthusiasm in the students, and I'm sure that if we offer some elective like this, definitely we'll have a lot of takers.
I'll be more than happy to engage, Ms. Thomas. I am glad you feel that way, and I think we also want to do our bit in this process. We want to educate them. We want to bring them forward. So I'll be more than happy to.
Wonderful, sir. So I will definitely get in touch with you. Okay. Right. Thank you so much. Thank you so much.
Thank you very much for for inviting me, and thank you for your time.
Yeah. Thank you so much, sir. Over to you, Pragati.
Thank you so much, ma'am.
Okay, sorry. All right.
Now that we have come to the end of today's program, I would like to invite Ms. Anushka Thakre, Executive Committee Member at IEEE CIS Student Branch Chapter, to deliver a vote of thanks.
Thank you, Gauri. Good evening, all. As all good things come to an end in life, so is today's Power Talk session. On behalf of entire team, I, Anushka Thakre, ExCom member at IEEE CIS SBC, take this opportunity to propose the vote of thanks. Our sincere gratitude goes to our guest of honor, Mr. Raghu R. Krishnamurthy, for sparing his time to deliver an excellent Power Talk session on topic Demystifying Blockchain. I would like to thank our Honorable Director, Dr. Sachin Untavle, GH Raisoni College of Engineering, for his great support. I also wish to express my gratitude to our chapter advisor, Professor Achima Thomas, for guidance and constant support that radiated a source of energy within us. An event can't happen overnight. It needs planning and hard work. We have been fortunate enough to be backed by a team of very motivated and dedicated members who do their best to make events like this possible. I cannot thank each one enough for the involvement they've shown and the willingness to take the completion of the work beyond their comfort zone. Well, stay tuned with us because we have lots of fun events coming this year. I request all the attendees to fill the feedback form for this session in order to receive the e-certificate.